Let's do integral number 10. This one is a little bit more complicated. Integral of the cosine of x divided by 5 plus 4 cosine of x. Let me zoom out a little bit, like this. Okay, so let's rewrite the cosine of x in terms of the tangent of x over 2. In particular, we can rewrite it as cosine of x over 2 plus x over 2, and this is equal to cosine squared of x over 2 minus sine squared of x over 2. Now, let's rewrite this in terms of the tangent. So we can rewrite the sine squared of x over 2 as 1 minus cosine squared. So we get 2 cosine squared x over 2 minus 1. And then we know that 1 over cosine squared of x over 2 is equal to 1 plus tangent squared of x over 2. So this is equal to, it's 2 divided by 1 plus tangent squared of x over 2 minus 1, and this is equal to 1 minus tangent squared of x over 2 divided by 1 plus tangent squared of x over 2. We will need this, so this is something that I'm going to use. Then let's do something similar also for the sine. The sine of x is equal to 2 sine of x over 2 times cosine of x over 2. Let's rewrite this as tangent of x over 2 times the cosine squared of x over 2. This is equal to 2 tangent of x over 2 divided by 1 plus tangent squared of x over 2. So let's remember this. Let's use the substitution u equal to the tangent of x over 2. So we are going to replace this and put it inside the integral. We are going to make this substitution in the integral there. So the integral of the cosine will be integral of, instead of the cosine, I will put this formula, but using u instead of tangent of x over 2. So we have 1 minus u squared divided by 1 plus u squared, and then we have to divide by 5 plus. Then we have 4 cosine x, but the cosine of x is still 1 minus u squared over 1 plus u squared. We have to multiply this by 4, and also we have to find the x. How can we find the x? We can find the x in terms of du from here, because x is equal to twice arctangent of u, and dx is equal to 2 over 1 plus u squared du. So here we get 2 over 1 plus u squared du, and this integral here is equal to, we can rewrite it, it's integral 2, so we can factor out 2, 1 minus u squared divided by 1 plus u squared, and this multiplies 5 plus 5u squared plus 4 minus 4u squared. So this is 9 plus u squared, and then here we have du. We can try to rewrite this like this. So we have a over 1 plus u squared plus b over 9 plus u squared. And I mean, all this integrand here, we can rewrite the integrand like this. So this is equal to a times 9 plus u squared plus b times 1 plus u squared divided by 1 plus u squared times 9 plus u squared, and this is equal to a plus b u squared plus 9a plus b divided by 1 plus u squared, 9 plus u squared. So a plus b should be equal to minus 1. You can see that from here, from this minus sign. So a plus b should be equal to minus 1, and 9a plus b should be equal to 1 from here. We have to solve this system of equations, and maybe we can subtract this equation from this one. So from that we get 8a equal to 2. So a should be equal to 1 over 4. If a is equal to 1 over 4, b is equal to minus 1 minus 1 over 4, which is minus 5 over 4. This is the other one. Therefore, we can rewrite the integral above like this. We have equal here, equal to, then we get integral of 1 over 4 du over 1 plus u squared plus 2 integral minus 5 over 4 du divided by 9 plus u squared. Therefore, here we get 1/2 arctangent of u minus 5/2 integral du over 9 plus u squared. We can factor out this 9 here, so we can rewrite it as 5 over 18, and here we get 1. Here we get u over 3 squared. We also need to put a factor of 1/3 here inside this differential. So 18 is 9 times 2, or 3 times 6. So in here I will be left with 6. So it's 5 over 6 times this integral here. And this is the arctangent of u over 3. Remember what u is. U is just the tangent of x over 2. So the result is 1 over 2 arctangent of the tangent of x over 2. So this is just x over 4, the first one, minus 5 over 6 arctangent of the tangent of x over 2 divided by 3, plus a constant if you want. And this is the result of the integral.